Hi guys, you are welcome to our class today. So in this particular class, we are going to look at, just a few questions from chapter 2 of Unizik Physics 102. We are going to look at question number 5 and question number 7. I was actually supposed to be solving question number 4, right? 4, 5, 6, and 7. But question 4 and 6 cannot be handled in a live class like this. There's a reason. You have a graph there. And of course, I need to make reference to the graph as I am solving that question. So hopefully tomorrow, by God's willing, let's see how it goes, I would release a pre-recorded video that will allow me to make reference to the graphs as I solve those questions. So this particular class is going to cover question number 5 and 7. All right. So you are all welcome, dear friends, to this evening class. Tina, good evening. You're welcome. Desire, good evening. Favor, good evening. You're welcome. Williams, you're welcome to the class. Henry, good evening and welcome. All right, as usual, please help me share this link, all right, to your departmental WhatsApp groups, to your friends and classmates, then encourage them to join the class. Let us kick off right away. We have limited time. Okay, so like I said, we are going to look at question number 5. That's the first question we're going to deal with still on chapter 2 of the work, right? So question number 5. Like we know, I am not going to copy the question on the board. I will just draw this diagram because we have this particular circuit given. We are still in the current electricity circuit, a city, okay? That city of current electricity, but it's not in Nigeria. It's not Nigeria, yeah. So we have this diagram, and this is the cell. This is the cell. Then we have this resistance. That's the internal resistance of the cell. Good. So we've got the diagram this way. Of something like this. And then we have the values as given. This is 9 volts. 9 volts. We have R here. Use this. This is 2 ohms. This is 2 ohms resistor. This is 6 ohms. This terminal was labeled. This terminal was labeled as AB. Good. That is it. I'm going to dictate the question linked to this diagram as you have in your manual. A battery of EMF 9.0 volts and internal resistance R, small r, okay, is connected in the circuit shown in the figure below. So this is the circuit. A part of the question, the current in the battery is 1.0 ampere. The current in the battery is 1.0 ampere. I, that is question I, because AI. Calculate the potential difference, PD, between point A and B. So we are asked to calculate the potential difference between A and B. That's what we are dealing with. Now, in the question, as given a part of this question, the current produced by this battery, by this cell, this 9-volt cell, the current is given to be 1.0 ampere. 1.0 ampere. Of course, if this cell is producing 1.0 ampere, we expect that that current is going to flow this way. So the current in the circuit is 1.0 ampere. Are you following, right? That's the current in the circuit. By the way, I hope you had a wonderful day today in school and in others of your activity. Sorry, I didn't ask. Just trying to have us work on this before, now network and it's wahala. But we hope that we will scale through very well. in this particular evening class. Okay, so if current is produced in this circuit, the current is going to flow this way. And of course, we know at this point, the current will branch into two. So you have this I flowing through these 2 ohms resistance. You have current flowing through these 2 ohms resistance. And there's something that is interesting you want to take note of here. These 2 resistors are connected in parallel. Because they are connected in parallel, current shares. This total current of 1 ampere is going to share at this point A. One will move through this resistor, the other will move through these 2 resistors. Interestingly, the resistors, they have the same resistance value. And because they have the same resistance, exist across the resistors. So the voltage here and the voltage here, they are equal. Does that make sense, right? They are equal. So you want to take note for that. For parallel circuit, they have the same voltage. And then they have different currents. However, if the resistors, like in this case, are the same, although the current will share here, but the same current will flow through them. That is just a coincidence here because these 2 resistors have the same resistance value. Otherwise, generally, a parallel connection divides current, and it is expected that the current will be different. I hope I'm communicating right. Okay, let us move on and calculate the potential difference. Like I said, if you get a potential difference for this 2 ohms resistance, you have gotten the potential difference between A and B. The reason I have said before, parallel circuits, they have the same potential difference. The network has started again. So I'm trying to see what I can do about the network. Come up. Okay, I think the network is back. We'll continue to manage, because of where we find ourselves in this part of the world. Williams anointing, this is my first time in your class. I hope I've not missed much. I wouldn't say whether you've missed much or not. Okay, the truth is we've been having classes, but you can get to find out what we've done in our live section. So on this channel, go to the live section, and in the live section you will see all we have covered. Okay, but for this evening, this is our first class. This is our first work for this evening. This network, please allow us to rest. Let's breathe for once. Okay, so where are we? We've solved the first part of the question. Like I said, we got the potential difference across point A and B. Point A and B, we got the potential difference to be 1 volt. I'm so worried about the network. It's hanging somehow, I don't know. All right, the second part of the question, we are asked to calculate the internal resistance of this circuit R. That is II. Internal resistance, we have to calculate it. We use small letter r to represent internal resistance we do not know. So how do we calculate the internal resistance of this circuit? Now we know the electromotive force value to be 9 volts. To obtain the internal resistance, we'll have to use the formula. Recall that I is equal to E all over R plus capital R. Now we know the electromotive force value already, and the electromotive force value given in the question is 9 volts. It's 9 volts. That is the electromotive force value, 9 volts. So we know E. Now we know the current in the circuit. The current in the circuit is 1 ampere produced by this battery of EMF 9 volts. So we know this one. We know this one. We are looking for small r. We don't know small r, but we know this big R. This is the external resistance. Why did I say that we know the big R, which is the external resistance? It is because we can resolve these resistors here. We can resolve and get their resistance value. So let us quickly go and obtain our external resistance R. So I can say that, but R is equal to this and this, they are in parallel. If I resolve this in parallel, I will now resolve it together with this 6 ohms single resistor. Are you following, right? The value of that resistance will be in parallel to this 6 ohms resistor. So what you're going to get here and what you're going to get here, all you have to do is to add them together because they will now be in series. This whole unit is in series with this 6 ohm resistance. Now I'm going to show you something a bit crazy. Yeah, whenever you see a problem like this, these two resistors are in parallel. Yesterday I did something like, to get the effective resistance here is going to be multiply both of them and divide by the addition of both of them. Now let me tell you something. Whenever these two quantities have the same value, whenever they have the same value, and you want to get the resistance, say, of this part, there are still some other things you might want to do in order not to stress yourself if you so wish. If you so what? Wish. You can do that. For example, you can pick one of these and divide it by 2. So watch, let me show you what the formula of this unit is going to be like. The total resistance, external resistance, since this and this, they have the same value. Please, what I'm about to do for this unit, this parallel side, is because the two resistors have the same resistance value. So you can actually do this. Instead of doing your 1 over R equal to 1 over R1 plus 1 over R2, let's take this as R3 and then plus R3 because R3 is in series to this. Or instead of doing R1 times R2 all over R1 plus R2 and then adding to R3, you can do this because, take note of the reason, because this resistor and this resistor, they have the same resistance value. I can do this, watch. Pick one of the resistors. So I can say R1 divided by 2. What you are going to get will be the same if you decide to use your normal, formula for calculating resistors in parallel, or use that which you saw yesterday for 2 resistors that are in parallel. I've talked about it. I can just pick one of these two guys, either R1 or R2, then divide it by 2. Whatever I will get from here, which is the value of this parallel unit, that single resistor I will obtain from here will now be in series with this R3. So for that reason, I'll add this to R3. I'll add it to R3. So the total resistance, the external resistance value here is going to be R1 is 2 divided by 2 plus R3 is 6. So R1 is equal to 7 ohms. Is it R1, or the effective external resistance is equal to 7 ohms. Now that I've obtained these 7 ohms, this is cool. I can now come to this formula and then substitute. In place of current, I'll fix 1 ampere equal to the electromotive force is 9 divided by internal resistance. We don't know, that's what we are looking for. Add it to the external resistance, which is 7 ohms. So take note of this. Yeah. If your technologies decide to test this particular electrical experiment, that they will ask you to derive that for 2 resistors that are equivalent, if R1 is equal to R2, prove that R is equal to R1 over 2. It's very simple. You want to learn more, become a channel member, or if you prefer joining our physical tutorial class, of course, remember GMAETS 41 holds tutorial classes for you friends in Unizik, those that are in Unizik. So if you simplify this, you are going to get the internal resistance to be equal to 9 minus 7, and the internal resistance will be 2 ohms. From here you cross multiply and then collect like terms. So we are done with this second question where we will asked to calculate the internal resistance. That is the value. Please take note, this R1 over 2, I could have done, to get it from here, I could have done R1 times R2 divided by R1 plus R2. Or I could use the normal thing when you are proving or deriving the value of effective resistance for resistors in parallel, could do 1 over the overall resistance for these 2 R1, R2. So let us say 1 over R1, 2. The equivalence of these 2 resistors will now be equal to 1 over R1 plus 1 over R2. So this formula you are seeing here is the same as this formula. And when the resistors are equal, it's the same as this formula. You apply it in the case of just two resistors. Take note. All right, we are moving on. Nnamdi. Good evening, boss. I'm Loya. Good evening. You're welcome to join our class. I hope you're fine. Okay, let us move on. I think the next question we have here, let's see. We are done with II. So the next one is III. You are asked to calculate the energy dissipated in the circuit. That is the third part of the question. The energy dissipated in the circuit. So III, the third part. Energy dissipated in the circuit, you don't know. Energy dissipated in the circuit, you do not know. Now, you want to recall that the formula for calculating energy, you can use I squared RT, you can use IVT, you can use V squared over R, then times T. Remember, generally, energy is power times time. And power is I squared R or IV or V squared over R. So the choice is yours. I guess we have all the data we need here to get power. Power is equal to PT. Energy rather is equal to PT. Or you can say E is equal to I squared RT, I squared RT. And that's also equal to IVT. And that's also equal to V squared over R times T. These three formulas, four formulas, are used for calculating power. The one you use depends on the values given to you in the question. So let us move on. Let's see what we can do. I think we know our total current already. We know the total resistance in the circuit. And we were actually asked to calculate the energy dissipated in this circuit at a particular time. The time given in that particular question is 5 minutes. Yeah, 5 minutes. So we are given T equal to 5 minutes. 5 minutes. Energy, you don't know. The time during which you have to calculate the energy dissipated is 5 minutes. Of course, you have to convert these minutes to second by multiplying it by 60. But I'll just have it work together. We shall use this formula, I squared RT. Okay, I think our R is 7. I avoid this issue of square. Even if you do square, 1 square is still 1 because the total current is 1 there. Anyway, let me use IVT instead of I squared RT. Let me use IVT. But confirm using I squared RT, you still get the same thing. I is 1 ampere. Multiply it by voltage. The voltage is 9, which is the EMF. And then multiply it by the time. The time is 5 minutes rather. And then you multiply that 5 by 60 to convert to second. So if I multiply this, what am I going to get? 5 times 60 is 300. 300 times 9, 2700, right? 300 times 9 between 700, that is 2700. Multiply by 1, you still get 2700. The unit will be in joule. The unit will be in what? Joule. Good. So we have calculated the energy dissipated in the circuit. If you use I square RT, like I said, I is 1. 1 square is 1 times R, which is 7. Then 7 times T. 7 times T. T is 5 times 60, which will give you 7. That's 300, like we said. Yeah, 300 times 7, right? That's what you get there. Okay, the R there totally is meant to be 9. Because the resistance you are going to use here, please take note. The resistance value you are going to use here will be equal to the overall resistance in the circuit. Look at it. This plus this. So you are not using this 7 directly. Take note. I'm sorry that the formula came in this format. In this circuit, there are 2 resistors. This one, the internal resistor, and this whole external resistor. All of them oppose current here. So in the case of this, the formula actually for this circuit, is meant to be I square R plus R. That is internal resistance plus external resistance. You have to add both of them. So you get that 9 there, and then you multiply by that value to get what the correct answer should be. All right, so that is that. The next question, we are asked to calculate the energy dissipated in the internal resistance. Please round off what you have on the board. I'm going to wipe it. We're going to look at the energy dissipated in the internal resistance. Energy that is dissipated here, right? Okay, I'll wipe this A part. AI. So we go. Remember, at the end of this live class, a copy of this video will be made available. A copy of this live class will be made available. Become a channel member so you can get access to it. Are you following, right? To become a channel member, join GMAETS 41 on platinum level or on diamond level. The higher the level you join, the more benefits you get. Please support this channel. Support GMAETS 41. Support me. I will appreciate. Platinum level is 2,000 monthly. Diamond level is 4,000 monthly. Okay? For those that wish to join GMAETS 41's physical tutorial in Unizik, please start now. There is no time. I think 4 to 5 weeks. This is the 5th week of school resumption. Time is going now. The earlier, the better. And if you are in our online space, make sure you are consistent with our class. So energy dissipated in the internal resistance, permit me to use E subscript R. E subscript R. That's what we are calculating. We don't know. So what's going to be the formula is just simply going to be E subscript R equal to I squared RT. Good. In this case, look at, you're using this formula. The resistance formula or value you're meant to use is that of the internal resistance because you were asked to calculate the energy dissipated in the internal resistance. For this one, I use R here. Let me just fix something. R total is small t. I hope you won't be confused. You can hear me as I'm explaining the implication of this. R total. So let me just write something here where R total is equal to R plus R. That's what I use in solving this. But I use IVT anyway, so it doesn't matter. Let us move on. So this is now going to give us R equal to, current is 1, you square it. The internal resistance, we obtain the value to be what? 2. So this is going to be times 2 and then times the time. The time is 300, no need of wasting time. 300, which is 60 times the 5 minutes given in the question. Single Beauty, good evening. You're welcome to the class. You're welcome. If you multiply this is going to give us 600, right? 600 joule. 600 joule. So we have calculated the energy dissipated in the internal resistance. We are moving on, guys. We are moving on. And I hope you are grabbing what we are talking about here, grasping the point. Okay, it's just about you take a full class on current electricity. On this channel, you have the full video lesson, lecture video on current electricity. Super lecture videos. Now, once you take them, there is nothing about current electricity you can deal with. And then you want it in a physical tutorial. If you're a Unizik student, contact GMAETS 41 using this contact. Look at it, please. If you're contacting me on WhatsApp, all right, on WhatsApp, take note of that. Send a message on WhatsApp, and then if you must call me, then call in the daytime, right? In the daytime, they're about 10 a.m. or 11 a.m. But I prefer message on WhatsApp. It's best. Now, the next part of the question, which is what do we have here? IV, right? Is it IV? Oh, no. Not IV. Let's see. I think in that IV, you are asked to calculate the energy dissipated in the internal resistance. And then you should go ahead and calculate percentage of energy. Let's see. Percentage of energy calculated in part III. That is dissipated in the battery in 5 minutes. So you are asked to calculate also the percentage of energy which you calculated in III. Percentage of energy which you calculated in III that is dissipated in the battery in 5 minutes. Look, I have III. What percentage of this III part, that is, what percentage of the energy you calculated here, which is 2,700, is dissipated in the battery, is given off in the battery in 5 minutes. Remember all these calculations with DJs with respect to 5 minutes. So what percentage of the energy here was dissipated in the battery in 5 minutes? So I want to find the percentage of this that will be dissipated in the battery. Now, for this battery, for energy to be dissipated, kind of lost per se, are you following, right? In that battery, it is as a result of the internal resistance of the battery. Because internal resistance of the battery is due to the chemical reactions of the cells, of the chemicals that are inside the battery. So when these chemical reactions are taking place, they produce, what is called internal resistance, which is the opposition to the flow of current offered by a cell, by the chemical component of a cell. Opposition to current flow offered by the chemical component of what? Of the cell. So these are the things you want to take note of. What percentage of this energy here is dissipated in the battery? So you now ask yourself, what on earth, right? What is actually responsible for this energy to be dissipated here? And what is responsible is this internal resistance. Good enough, you have calculated the energy dissipated in the internal resistance. So if I'm using the word lost, the energy that is lost, right, because of the internal resistance, you have gotten it. So this energy now will form the percentage of this guy, of this total energy that will be dissipated in that battery. Take note in III, the energy calculated there is the energy in the circuit, energy dissipated in the circuit. Why this one is energy dissipated in the internal resistance, and this internal resistance, the component of the cell, is opposition found in the cell. So we are going to express this as a percentage of this guy. Does that make sense? And this is what we shall have. Let me, I don't know, I think I will proceed directly. The question comes in this way: percentage of energy. Percentage of energy dissipated in the battery, right? Percentage of the total energy, percentage of, permit me to write total energy, because they linked it to the energy calculated in III, dissipated in the battery, is going to be energy dissipated in the internal resistance, or energy dissipated in the battery per se, right? In the internal resistance divided by total energy dissipated in the cell, then multiplied by 100. Because if you simplify this, you get 600 divided by 7,200. Because is it 7,200 or 2,700 rather? 2,700. Then you multiply by 100. Percentage of this dissipated. Just this part that is lost in the battery, right? So it's going to be this over this times 100. So that's the idea. If you simplify this, I hope you are going to get 22%. 22%. And that is the answer. That's the percentage of the energy in III dissipated in the battery. 22% is dissipated. No wonder, you see, like I taught my students in the physical tutorial, and then even in the online class, of course, we've covered that already under current electricity. If you buy a battery now, and maybe on the battery, it is written that the electromotive force is, let's say, 1.5 volts. Say the electromotive force, EMF, is 1.5 volts. Take a voltmeter, the instrument used in measuring voltage. Take a voltmeter and measure the electromotive force. Take a voltmeter and measure the electromotive force. You will find out that the EMF you are going to get will not be exactly 1.5. It won't. It will be a bit less than 1.5, maybe 1.49 or something. This is as a result of the lost voltage. There is something we call lost voltage, which is still due to the internal resistance. To learn more, become a registered member. You can register for our physical tutorial, like I said. If you are a Unizik student, you can register for our full online tutorial where you get access to everything still, right? And then you get added to our WhatsApp group for registered students. You can also choose to become just a channel member on platinum or diamond level. If you join the diamond level, please, immediately you are joining, send a message to this contact on WhatsApp, indicating that you've applied for diamond level, because there are some benefits that you still need to get. Okay, we are done with this particular question, and I hope you learned something in it. We shall be moving on to the next question. Let's see. I think we are done with everything in question number 5. Yeah, as required in your manual. So finish up. I'm going to wipe the board so that we move on to question number 7. Like I said, I cannot deal with question number 6 because there is a graph attached to it. It's going to be a pre-recorded video so that at least as you see my analysis, you'll be seeing references made to the graph. A lot of calculations we do there, we extract it from that graph. Okay, so we're going to skip question 6 and then take question 7. We're going to skip question 6 and then take question 7. So finish up. Let me wipe the board and then we move on. Hello, sir. I am from India. You're welcome to join us from India. I hope you friends are doing fine here in India, right? So make sure you always connect to our class. If you have not subscribed, please subscribe now. Click the subscription icon. Then turn on the notification bell. You will see a bell icon. Turn it on, right? When you turn on the notification icon, if you click it, you will see all personalized. Usually personalized is ticked by YouTube for you, okay? Yeah, by default, that personalized is ticked. Select all. This I'm telling you is free of charge. Take note. So don't be scared of wanting to subscribe and turning on the notification bell. It is completely free of charge. Are you getting me? The reason why you have such, room on YouTube is for you to always get information about, GMAT for the ones classes. Once I kick off any class or I upload any video, you will be notified by YouTube. For example, I've told you tomorrow, solution to question number 4 and 6, because these two guys, they contain graph, will appear. It's going to be a pre-recorded video lesson uploaded. If you are not subscribed, number 1, and if you have not turned on the notification bell and select all, you may not be notified that that video is available already. So please make sure that you do the needful. Share these links to your friends. Invite them to subscribe to this wonderful channel. Let us move on to question number 7. I'm wiping this. Question number 7. Before I dictate the question, let me see if I can quickly draw this. We have a diagram like this. We have a diagram like this. Then we have these strips. Think 1, 2, 3. 1, 2, 3, 4, 5. 4, 5. So we've got something like this. Don't mind what I drew there. It's freehand. This is 0 volts. And then it seems like we have something like the output. The output. And this is 12 volts. Volt. The volt was written. Then this was labeled as copper. Copper. So the material is made of copper. resistive strip. These two were labeled as resistive strip. This and this, they are resistive strip. That is a strip that has resistance. Resistive strip. At least I have to draw this diagram so that, you know, other people from different schools and different parts of the world connecting to this class will at least have a preview of what we are solving. This class is based on Nnamdi Azikiwe University, Unizik, in Nigeria, right? Their physics 102. So we have this diagram. Follow up as I read the question. The question connected to this diagram. So let's see what we've got. And the question goes this way. A heating unit, heating unit, H-E-A-T-I-N-G, like someone feeling hot, right? A heating unit is used on the rear window of a car, right? A heating unit as used on the rear window of a car consists of 5 strips of resistive material joined at either end by strips of copper of negligible resistance, shown in the diagram below. Heat is generated at a rate of 45 watts when the unit is connected to a 12-volt car battery. Then we now have this diagram. Are you following right? I'll read the question again, but this time I'll be fast. A heating unit as used on the rear window of a car consists of 5 strips of resistive material joined at either end by strips of copper of negligible resistance, shown in the diagram below. Heat is generated at a rate of 45 watts when the unit is connected to a 12-volt car battery. So we have this. These are the resistive materials. They are called strip also, according to the question. Now, this you're seeing here is copper. It's copper. And the question says, look at it. The question said that the copper has negligible resistance. So the copper, we don't consider the resistance of the copper. It's negligible, its resistance. Now, we are told that this strip you have here, all right, that it generated a heat at a rate of 45 watts. Heat is generated at a rate of 45 watts when the unit is connected. That is when this is connected to a 12-volt battery. When you connected this unit to a 12-volt battery, the heat generated, according to the question, although heat was used, but if you look at, we are told that it is 45 watts. Watt is not the unit of heat. Generally, watt is the unit of power. But the reason they use heat there, that is rate of heat. Rate of heat. So heat is generated at a rate. The rate of heat is equal to power. Because if I have heat, heat is a form of energy. So heat is also energy. Are you getting me? Rate of heat is heat over time. And heat over time is equal to energy over time, which will give you what? Power. The rate at which work is being done. The rate at which energy is being expended. So that heat is generated at a rate of blah, 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 45 watts. That 45, please take notes. It is power. So here I'm going to write, according to the question, power, which is heat over time, rate of heat generated is equal to 45 watts, according to the question. Now I have interpreted the question for you. I've interpreted the main question. So after the question, we now had this diagram to refer to that question. Now the follow-up question here, A part of the question says you should calculate the total resistance of the unit. A part of the question, calculate the total resistance of the unit we do not know. Total resistance of the unit we don't know. I hope the network is still intact. Good. I love that. Let's see. Good, the network is still on. I don't understand question 3 and 4. Which one is question 3 and 4? Single beauty. Can you specify? You see question 3 and 4 of this particular question, and when you see question 3 and 4, I don't really get. Please use the numbering that I am using here, because I'm using the exact numbering I have in the source of the question I am solving. Okay, please. But if it is question 3 and 4 of this particular manual, I've solved question 3 yesterday. Question 4, I've told you we can't solve it in the live class. There are graphs I need to make reference to. If it is III and IV you are talking about, maybe question number 5, the III part and then the IV, then indicate using that numbering so that we know the question you're referring to. Okay, the I part of the question, total resistance of the unit, we are asked to calculate it. We don't know the total resistance of the unit. So how do we calculate the total resistance of the unit? Good enough, we have the power. The rate at which heat is being generated is 45. And we also know the voltage, right? We know the voltage. When this unit is connected to a 12 volts car battery, it generated this heat. So from there, we are going to recall that power is equal to square of voltage divided by resistance. So from there, if you fix up the value, calculate for resistance, the resistance will now be equal to square of voltage, which is 12, you square it, then divided by P. P is the power, which is 45. So you can reach out for your calculator and evaluate that. 12 squared is 144, at least I still remember that one, right from primary school when we sing 2 times 1, 2, 2 times 2, blah, blah. 12 times 12, 144. Go and cram your multiplication table, at least from 2 to 9 times table. I've been singing it. Divide this by 45. Dividing this by 45, I got 3.2. So the total resistance of this unit is 3.2 ohms. 3.2 ohms. 3.2 ohms. That's the answer. Now the second part of the question, we are asked to calculate, okay, show that the resistance of each strip is about 16 ohms. Show. It's like a proof. Are you following, right? That the resistance of each strip is about 16 ohms. So how do we prove that? Once again, it is simple. We know the total resistance of this unit already. How many strips do we have here? 1, 2, 3, 4, and 5. Now, in the question, there was no statement that showed that the strips are made up of different material. Nothing like that. The question did not say anything that these strips you have here, they are made of different materials. No. It simply means that the strips are made up of the same material. That is the assumption we apply here. Because the question didn't say that they are made up of different materials. They are made up of the same material. Point number 1 you want to take note of. Then secondly, every condition, right? Every condition, say temperature, the voltage, the power, applies to each of them. What is happening in this strip is what is happening in this strip is what is happening here. Because of course, the whole strip was connected to the same source of voltage or potential difference. Now, if that is the assumption, it means that the resistance here in this resistive strip and the resistance in this resistive strip, the resistance in this resistive strip, the resistance in this resistive strip, and the resistance in this fifth resistive strip, all of them are equal. And that is why the question says we should show that each of them is 16 ohms. It's about 16 ohms. So what do? We have to move on straight and calculate. If that is the case, okay, I can say that R1 is equal to R2 is equal to R3 is equal to R4 is equal to R5. And we are saying that we should prove that it is approximately equal to 16 ohms. That's what the question is saying. Now, if that is the case, recall, total resistance in the strip is 3.2 ohms. So if you now like, you can do I'll wipe it, but let me show you. 1 over total resistance equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. Once you understand what you are doing very well, there are a lot of things you may not need to do, or there are a lot of steps, processes you may not need to follow. Look at this. R1 is equal to R2 is equal to R3, blah, 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 and the rest of that. Which means if you find the LCM, you have the same value as LCM. Let's say that the LCM now is R1, I'm assuming it's R1. And we are trying to calculate that each of them has this value. So we don't know the value of each of them. But the examiner is saying, show that each of them has a value of about 16 ohms. How true is that? Can we prove that? So in this case, you can replace each of them as R1, R1. Because, like I said, all of them have the same value. And if this is R1, 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 in that case, if you work on this, using LCM as R1, add up the numerator, you're going to get 5 over R1, which means that this thing you are seeing, on the basis of this condition that all the resistances are the same, 1 over R1 will now be equal to 5, sorry, 1 over R, 1 over the total resistance will be equal to 5 over R1. You can check on that. Replace each of this R stuff, you know, R1 here, R2, R3. All these R2, R3, R4, and R5. Call them R1, R1, R1 on the condition that each of them has the same value, about 16 ohms. The unknown resistance value and then prove that that X is about 16 ohms. If you work on this, you get 1 over this equal to 5 over R1. All right, so having done that, an insect is just disturbing me here, you know. A lot of people like my class, even insects, wants to come and learn the concept of the current electricity city. Okay? The insect wants to come and learn about it. But I will fire the insects soon anyway. So from here, dear friends, all we just have to do is substitute the value. You see this formula and this formula the same thing because all the resistance are assumed to be equal. And I think from here, I can get R1 straight. R1 is going to be 5 times the total resistance. So R1 is now equal to 5 times 3.2. And then R1 is equal to, if you multiply this, 5 times 2 is going to give you 10, right? 0, carry 1. 5 times 3 is 15 plus the 1, 16. So you see that this is approximately 16 ohms. Therefore, each of the strip has a resistance of approximately 16 ohms. Of approximately 16 ohms. We have done the work, okay? We have done the work. Onyeka, welcome to GMAT 41's Platinum level. Thank you for joining the channel. And you'll be glad you did because now you can access any lecture video on this platform. Welcome to becoming our channel member. Is this 2025 physics practical? No, it's not. Please, okay? For practical stuff, you can go to the GMAT 41's, this particular channel, go to the playlist. Then go to the practical section. For me, I don't believe in all this issue of interns. We are supposed to have taught our students everything about how to handle practical work so that by now, students will be relaxing, waiting for the examiner to bring question. Okay, let's move on anyway. Thank you, Aditya Kushresta. I don't know if I got the name. Great content. Thank you for the observation. All right, let's move on to the next question. The next question is B part of the question. Please, this one is II. This is II. So let's see. This particular question is AI, and then this one is AII. Then the B part of the question, let us see what we are asked to calculate. The question for that B part reads, please listen as I dictate it. For each resistive strip is 2.5 millimeter wide. I think there is a mistake in the writing there. I guess it should be, if each resistive strip is 2.5 millimeter wide and of length 0.80 meter, determine the thickness of each strip. Determine the thickness of each strip. I read that again. If each resistive strip is 2.5 millimeter wide and the length is 0.80 meter. Determine the thickness of each strip. This is cool, right? Now, in the manual, the examiner is asking if each of the strip is 2.5 millimeter wide. That's what the question said, 2.5 millimeter wide. And then the length, the width is from here to here, 2.5 mm. And the length from here to here, 0.8 meter. If that is the condition, you are asked to determine the thickness of each strip. Determine the thickness of each strip. So let us see how we conquer that question. Finish up what you have on the board. Like I've always said, you can make a screenshot if you want, or much later you come back, because at the end of this live class, a copy of this live class will be made available. Let us round off, please. We have just a little remaining before my generator will go off. All right, so we are showing that we are to determine the thickness of each strip. So this is what we do. Oh my gosh, my generator is going off already. My generator is going off. Please be patient with me. Let me see. How fast can I do that? I'm coming back. Be patient so that be patient, please. A moment. I'm trying to put up 1, 2 little connections. So we'll round off this particular question. So you guys see that what GMAETS 41 is going through is not easy. Huh? Let me appear so you can see. Why? Because of you friends. So support this channel, please. Huh? This is an online school on its own. Yeah, it's a full school determined to help you friends at this time when now our education system and other things, like we all know, if you're telling ourselves truth, is sinking. But the truth of the matter is, thanks to technology that have made it possible so that you can learn from the comfort of your home. Be patient. I'm doing high tension connection from here. All right, I don't know. I think let's see if we can manage up this so that we close the class. Let me track the level of reflection at that end. This is good. This is good. All right, so country name. This is from Nigeria. The class is streaming from Nigeria, okay? Our dear friend from, I think, India that's asking. All right, let's round off, please. Let's round off this question and we see what we've got. So we have to find the thickness. So what are we going to do? In the question, I think we're given one other parameter. we're given the resistivity of the resistive material. It was given in the question. The resistivity of the resistive material is 5.0 times 10 to the power of, I guess, to the power of minus 4 ohm meter. 5.0 times 10 to the power of minus 4 ohm meter. So here I'm going to write that R, resistivity. The formula for resistivity for this question, let me declare the data. The width is the same as breadth. Width is the same as what? Breadth. Because we talk about wide. So the width is equal to 2.5 millimeter. Convert this, you get 2.5 times 10 to the power of minus 3 meter. Then we're given the length. The length is equal to 0.8 meter. And then we're given what else? The resistivity. Resistivity, I use this symbol for it. So it's given as, that's the unit. So this is what we are going to do, right? We shall determine the area of this strip, right? In that area, you have thickness. Area is width times thickness concept. Are you following? So that's the idea we are going to use in this case. And this goes with the formula recall. Recall that resistance of a material is equal to, let me use this other shade of marker, blue. Resistance of a material is equal to resistivity times length divided by area. This is the formula for resistance of a material. And good enough, we know the total resistance of the material from the question. The resistance of the total resistance is 3.2, right? 3.2. Of course, you see, these guys, they are connected in parallel. That's another important thing I need to, talk about. They are connected in parallel. And that is why each of the resistor, each of the resistance value, 16, is greater than the total resistance. Because when resistors are connected in parallel, the total resistance you're going to get is less than the smallest resistance value is giving you 3.2. It is 100% correct. That's what is expected, okay? All right, so coming for each of the strip, what do we now do? We'll substitute our parameters. This resistance of each strip is going to be 16. Each resistance of each strip is going to be 16. Are you following, right? Let me put on a line. So it's going to be 16. And that 16 will now be equal to the resistivity, which is given, is 5 times 10 to the power of minus 4, multiplied by the length, which is 0.8. Think the length is 0.8 given. Let me confirm still, is 0.8. Good. Then we are now going to divide it by the area. Now, when you come to area, area is length times breadth. You can also solve area as length times height or width times thickness. You can solve it that way. Now, with respect to what we have here, the area is a part sitting on the ground. So it's going to be the width times the thickness. And we're given the width in the question. This area you are seeing, let me indicate it. Where A is equal to width times thickness. I'm going to use X for thickness. So in place of this area, I'm going to fix width times thickness. And the width is 2.5 times 10 to the power of minus 3 times the thickness. I don't know the thickness, X. So you fix X there. And with this, you can solve for X. Because of time, let's go straight on and do that. If you make X subject to the formula and you solve for it, you are going to get 1 times 10 to the power of minus 3. Therefore, X is equal to 1 times 10 to the power of minus 3. And this is going to be in meter because it's going to be in SI units. Or convert to millimeter. To change this to millimeter, what you have to do is to convert from millimeter to meter, you divide by 1,000. That is why I did this thing. Divide by 1,000, which is the same as multiplying by 10 raised to the power minus 3. So to convert from millimeter now, to convert from meter back to millimeter, you multiply this thing by 1000. And if you multiply by 1000, the 1000 will clear this 10 raised to the power minus 3. And that is going to give you 1. It's going to give you 1 mm. So the thickness of the material, the thickness of the strip, the thickness of each strip is 1 mm. Either it's a 0.001 meter or 1 mm. Remember, this is 0.001 meter, this particular value. So that is it. And we are done with this question. Let's see. I think we are rounding off already. Do you have any other question there? Okay, the last question. Yeah, the last question, which is C part. Let me check and be sure that the network is still okay and the light condition is still okay. Yes. Let's see. It's not easy. Trying to deliver of this good. This good. All right, let us round off with the C part of the question. Let us round off with the C part of the question. C part of the question. That is question 7C. What do we have here in question 7C? Listen as I dictate the question, please. The rear window heater on a car is sometimes set to be switched off automatically after a period of time to prevent draining the battery. The rear window heater on a car is sometimes set to be switched off automatically after a period of time to prevent draining the battery. If the charge stored in a fully charged battery is 1.44 times 10 to the power of 10 times 10 to the power of is it 5? Please let me check very well. I can see that. 1.44 times 10 to the power of 10 to the power of 5. To the power of 5. Okay. You have your manual there. I guess it's power 5. But someone can still type the power of that 10. I am solving the last question, the C part of question 7, which is the last question, please. Because I can't see that very clearly here, but I'm assuming it's 5. If the charge stored in a fully charged battery is 1.44 times 10 to the power of 5 coulomb, how long in hours would it take to fully drain the battery with the heater? So let me read this once and fast. The rear window heater on a car is sometimes set to be switched off automatically after a period of time to prevent draining the battery. If the charge stored in a fully charged battery is 1.44 times 10 to the power of 5 coulomb, how long in hours would it take to fully drain the battery with the heater? So that's the question given. The question we're given the charge, right? We're given the charge value. So we know the charge value. I'm using Q. And the charge value is 1.44 times 10 to the power of 5 coulomb. They're asking us to calculate how long in hour. We don't know. Time in hour. So let me write T in hour. How long in hour will it take for that battery, which is fully charged, to be drained? We do not know. We do not what? Know. So how do we calculate the time it will take for the battery to be fully drained, for the charge to be used up? So this is simple. We have charge here, we have time. There is one unique formula that connects time to charge. And that formula is, recall, Q is equal to IT. I know you are used to this formula because we have used it time and again on this channel. Q is equal to IT. So I am looking for T. I don't know in hours. I know charge. I don't know current at this point. So you see, for me to get T, Of course, you know that T is going to be Q over I. So it implies that T will be equal to Q over I. So I think our problem in this question is to calculate I. If I calculate current, my problem is solved. And how will I get current? Go back to the question, because this question C part is connected to everything we are dealing with. Are you following, right? Go back to the question. Now we know the power in this circuit. In this resistive strip, we know the power. We know the voltage that the resistive strip, okay, yeah, the whole unit, we know the voltage it was connected to. If I know power and I know voltage, I can calculate current. Now let us brainstorm. Use the network of our brain, because I don't want to solve current separately. I just want to substitute straight. Power is equal to IV. So I will now be P over V. I will now be what? Power divided by voltage. Which means, since I don't know the current value here directly, but I know the power and the voltage, I can substitute for it. So T will now be equal to Q all over. In place of current, I'll write P divided by what? V. This V will go up. T is actually QV divided by P. So directly, this is the formula one would have to use in solving it. Where this P is power. Please take note, this thing is not P. I usually use it for resistivity. I call it falling P, something like rho, okay? So it's different from this. This one is power, P. So from here, T will now be the charge is 1.44 multiplied by the voltage, which is 12, divided by the power. The power from the question is 45 watts. You still remember that? The rate of heat generated is 45 watts. I told you that is power. We already met it in the A part of the question, I guess. So fix 45 and then solve that. I think I missed out something here. This is 1.44 times 10 to the power of 5. Times 10 to the power of 5. That is the value of charge. Then multiply by the voltage, which is 12. So the T will now be equal to, let us evaluate this and see. I'm going to do 1.44 then times 12. Okay. Then divided by 45. So this gave me 0.384. 0.384 to now be times 10 to the power of 5. This T is still the same as 3. I want to move this point 1, 2, 3. Let's convert it to a whole number and see. If you have 0.384 times 10 to the power of 5 is the same as 384. Move the point 5 times. 1, 2, 3, 4, and 5. So I think that's meant to be 0, 0. 0, 0. You can always press that straight with your calculator. Okay? 10 to the power of 5. 10 raised to the power of 5. And then multiply by 0.384. And then you will get 38,400 as I have here. The unit of this time will be in second. The unit of this time will be in what? Second. Reason. All the quantities we use here, their units are in SI. Are you following, right? Their units are in SI unit. So when you calculate time, that time will also be in SI unit. Onyechi Favor, thank you very much for helping us to know that the power is 5. That's good. I am glad, so that we know what we are doing here straight on. So this is the time it will take the battery to be fully drained in seconds. We are expected to convert this to hour. So how do you change from second to hour? You know, to change from hour to second, you divide, right? To change from hour to second, you multiply by 3,600, because 3,600 seconds is equal to 1 hour. If 3,600 seconds is equal to 1 hour, then 38400 seconds will now be how many hours? So what we have to do to change from second to hour, you divide this second value by 3,600 seconds. So this is equal to 38400 divided by 3600. So the time in hour will now be, let's reach out for a calculator, 38,400 divided by 3,600. Divided by 3,600. And if you do that, this gave me 10.66 hours, right? which is equivalent to 10.7 hours if you approximate. Time is usually into two decimal. So let me leave it in 2 decimal. So it's going to be 10.66666, so 10.67 hours. So it's going to take 10.67 hours for the whole battery to be drained. Wow. This is great. We've done something good. Managing the situation of light that we have after my petrol gets exhausted. You see, the whole petrol in the petrol tank of my generator has been drained. How long did it take for it to be drained? If the power that was being consumed by the bulb here is 45 watts, and then I tell you, okay, that the charge entering the bulb is 1.44 times 10 to the power of 5. So tell me the time it will take an hour, or it took an hour for the whole petrol to be drained. That is a similar kind of question. And I hope you understand and appreciate what we have done on the board today. We are done dealing with question 5 and 7 of your chapter 2 of Physics 102 manual for our dear students in Unizik. It's left with question number 4 and 6. Like I said, I will be providing a pre-recorded video lesson on that because there are graphs I need to be extracting information from. I can't do it if it is only for Unizik students that I'm doing this per se. Yeah, it targets Unizik students because of their workbook, but other people are also learning. So if I'm doing such in a live class, they should be seeing the graph that I'm extracting this information from. The only way I can be able to deliver this lecture is making sure, or that analysis is making sure that the graph shows. I cannot present the graph now in this live class. Therefore, hopefully by tomorrow, that part will be available. If you have not subscribed, subscribe now, turn on the notification bell, and then select, if you click on that notification bell, select all. So that once I upload anything or I come on live anytime, you will receive the notification. Most of you did not know that there's going to be a class today, but likely maybe you have subscribed and turned on your notification bell. YouTube sent you a notification. That's good. Okay? Please remember that your support is fully appreciated. And join the GMAETS 41. Become a channel member. Through that means you are supporting this channel. As you know, as this channel is growing, it's giving you the best. And of course, contributing to the nation's education. Your younger ones would also benefit from this channel in time to come. So make it to grow. Become a channel member. Join on the platinum level or on the diamond level. The higher the level you join, the more benefits you're going to get. If you're a Unizik student and you're interested in physical tutorial, of course, some of you might prefer, okay, I'm doing online, but I also want physical tutorial. Contact me. This is the GMAETS 41's contact, right? Contact GMAETS 41 and then make inquiries about our classes. Get to know the venue where it holds on campus in Unizik. All right, so thank you for tuning in to the class, and don't have a wonderful night rest, and look forward to seeing you friends tomorrow. Finally, tomorrow in our physical tutorial, we have Chem 102. Chem 102. That is organic chemistry in our physical tutorial. By 4 to 6, we'll have that class. Pierre, and I'll be dealing with preparations and properties of the homologues that you are studying in Chem 102. So for dear Unizik students, I look forward to having you join us in our physical tutorial. Remain blessed and continue to do your best in your studies. Good night.